So to get started, we're going to be talking today about how to best visualize and operationalize your Firepower security events in your Splunk instance. My name is Greg Burson. I'm an engineering manager on the Firepower team. My team specifically deals with the Firepower Management Center, including all of the analytics capabilities, security policies, and system configuration and APIs. I came in through the SourceFire acquisition. I've been in Cisco/SourceFire for the past 11 years.
Good morning, everyone. My name is Jatish Joshi. I'm a software engineer in the Firepower Management and Integrations team. I primarily work on the threat-centric features on the next-gen firewall, so anything from URL filtering, security intelligence, and the threat intelligence director that we're going to cover in this demo. I worked on it, and I've been at Cisco for 3 years now.
So just go over the quick agenda of what we're going to cover today. We're going to go over Firepower in general, go over the eStreamer client and Encore Splunk app, the Cisco Threat Intelligence Director, how we're going to integrate Splunk and Firepower, do a lab demo of how all of that's going to work, and wrap up with a simple conclusion. So to start off, the Firepower Management Center. It manages all of the NGFWs and NGIPSs that are on your network. It includes multi-domain support, RBAC support, HA. It does all of your AC policy and intrusion policy configurations. It also does all of the analytics and has support for automated correlation and remediation. Now, the Firepower Management Center and all the Firepower devices produce a large number of events. This includes connection events, security intelligence events, intrusion events, file events. File events are all the file transfers over the network, and malware events are all of the malicious files that are traversing the network. Now, one of the main mechanisms we use to emit the events to other third-party applications is our eStreamer API. This is a proprietary API that is sent over a binary format that requires a client on the other end to actually take in the stream of data and convert it into logs that can be used within the application. Now, this could be kind of complicated for some of our clients, so we've produced a Cisco eStreamer Encore add-on for Splunk, which will take in the eStreamer events, convert them into a SIM-compliant format that Splunk can then ingest and use to visualize the events appropriately. The eStreamer client has been out for a little while now, over a year. It's currently on its 3.54 version, and it's available within Splunk base itself. So pretty easy to get. And if you want the link, it'll be in the presentation.
So we're in the age right now of having too much information. So whenever you see a new threat or a new attack, information about that attack is there from multiple intelligence providers. So when we talk to customers or users, they're like, what do we do with so much information? How do we consume it? So it's one of the major challenges that they face. Now let's say you manage to consume all that intelligence. How do you operationalize it? How do you send it down to all your network devices, your firewalls, seamlessly? So that's one of the other challenges they face. For example, let's say on your network, your firewall generated an event. It saw a connection to a malicious IP from which malware was downloaded. So if you look at these events discretely, you see connection to an IP, you see a malware being downloaded. Those are good. They tell you something bad is happening on your network. But what would be even better is if you can do complex correlation. By that, what we mean is, if you can tie in the IP and the SHA of the file to a specific attack that's taking place, that's going to help you know exactly what threat was on your network. It saves you a bunch of time, makes your analyst's life easier, instead of putting that in a SIM and trying to figure out, hey, did WannaCry hit my network? Or maybe is this an example of VPN filter? If you look at all these things, they have to be automatable as well. So you don't want to be doing this process manually, like configuring an intelligence source, downloading it, publishing it. So if it's automatable, it makes your life easier. What makes your life even easier is, are there APIs out there that you can use and integrate in your current workflow, so you don't have to change much? So to answer all these challenges, our answer was the Cisco Threat Intelligence Director. So the Cisco Threat Intelligence Director lives on the FMC, and it has the ability to consume intelligence from third-party intelligence providers. We've listed some of the intelligence providers here on the left. You can see Electric IQ, you can see ThreatQ, Infoblox. So this is a non-exhaustive list. There are a bunch of more intelligence providers that we support as long as they follow open industry formats. So what Cisco Threat Intelligence Director allows you to do is import intelligence in the sticks format, which means complex intelligence. So instead of simply having a list of IPs you want to block or a list of files, you can actually import intelligence which specifies rules that, hey, if I see a connection to this IP and I see this file downloaded, it means that this attack is taking place. So importing complex intelligence is supported. We support exchange formats like Taxi, so you can connect to a Taxi server, pull intelligence periodically, or if you want to do it the old way, which is you have a list of IPs you want to block, list of URLs, we support that as well. So it imports all that intelligence, consumes it, and operationalizes it. So it can automatically publish that to your next-gen firewall, next-gen IPS, and based on the actions that you've configured, it can block or it can monitor. And the events that are generated on your firewall, we convert those into incidents, which are then fed back up to the Firepower Management Center, where you can view them. And for this entire workflow, we have APIs available where you can configure the source, pull out all the incidents that were generated, and use that and integrate it in your existing workflow. So now we're going to move to a demo, and I'll hand it over to Greg.
Okay, so to go over the Splunk+Firepower lab, we have a sandbox available to you within DevNet. The sandbox is comprised of an FMC, an FTD, a Splunk server, and an Ansible server that's able to generate some events on the FTD for us. You can get to the sandbox via the link included in the presentation, and there's also a learning lab associated with this that will help you create the Splunk app that we'll start off with here. The Encore client is already set up on the Splunk server itself. eStreamer is already sending events to the Splunk server, so we'll just jump right into a Splunk app. Okay, so here we have a Splunk app that includes a visualization on the top of the events occurring over time. It's a stacked bar graph. The next visualization below that is going to be a cluster map that includes all of the events occurring across the globe, where they're originating from. We have top attackers, top targets, and then the transmitted malware. Now this is a good start. What we want to go ahead and do is edit this dashboard and add in some new panels from additional interesting visualizations. So we'll go ahead, edit the dashboard, hit add panel, we'll go down to add a bar chart, and we're going to make sure that it's utilizing the same time selector as the other widgets. So from here, we're going to go in and create a new widget that has the top attacks. What I mean by top attacks are top intrusion messages that have occurred on the network. Now these messages come from your intrusion rules that have been deployed down to Snort on the NGFW. And these rules themselves are created by our Talos team or imported in from custom rules that are available to the customers. So this query, pretty straightforward, is querying against the index eStreamer. The source type is Cisco eStreamer data, and we're looking at the top messages which come from our intrusion events. Going to go ahead and hit save here, and it's actually going to add to the dashboard. So it adds to the bottom dashboard. It's not the right location, so we're going to go ahead and move it up right in between the top attackers and top targets, so it's in a nice place for easy location finding as we go along. So we're going to add yet another panel. This time we're going to look for the top malicious URLs on the network. So these are all the URLs that were used to send malware across the network. So again, we're going to go ahead, add a new panel, add a bar chart, type in malicious URLs as the content title, and then put in a search string that's going to be very similar to the last one, where it's going to have the same index and the same source type, but this time we're going to look specifically at the record type of 125. This record type is for our malware events, and it's going to look for the top URIs that have been shown within those malware events. So here, add it to the dashboard, and we can now see all of the URLs that are actually sending the malware on the network. So this is good. we're now able to visualize a little bit more information about the events that are coming from our Firepower instance. But now, how do we operationalize this information? How do we create an intelligence source from this information within Splunk? What we're actually going to utilize to do this are lookups. So lookup tables within Splunk are normally used to enhance your event data by utilizing key value pair to have extra metadata available to you when you're doing your event analysis. But what it's backed by is actually just a CSV. And CSVs are essentially what we use as our intelligence sources. So we're going to utilize the lookups to actually include or append new IPs to them. So what this query is doing is it's first looking at the Firepower IP blacklist.csv input lookup. It's going to append the IP that's specified in the middle. It's going to remove the time column that's automatically added with each lookup entry. It's then going to deduplicate or remove any duplicate IPs from the list. And then lastly, it's going to output the lookup to the same CSV, so it persists the changes going forward. So when we run this query, we'll see that we're adding 888 to the list. And then here we can see we already had a couple IPs in the list, and we've now added 8.8.8 to the bottom. Now, we don't actually want to block these IPs right now, so what I want to do is just clean up this list. And there's a very good app for doing any type of manipulation within a lookup. It's called the Lookup Editor app. It's available within Splunkbase, and essentially allows you to interact with your lookups just like Excel. So here, I can go in, right-click on one of the entries, and simply remove them from the list. Now this is good. We now have a query they're able to run to easily add IPs to a list, but then how do we use our events to generate this query so that we can then actually add them to a list that can be used as an intelligence source within TID? To do this, what we're going to actually use are workflow actions within Splunk. Now we're going to create a new workflow action. This workflow action is available within settings fields. Once you load this page, at the very bottom, you'll see the workflow action selection. We'll go ahead and click on that. Click on New. And then enter in a name, a unique name for this workflow action. In this case, we're going to call it block source IP. And then we want to give it a label. Now this label is going to be shown whenever we do perform this workflow action within the Splunk app. So we want to make sure that it is informational enough so that you can act on the data. So what we're going to do is we're going to call it block IP or source IP in FMC and include a variable at the end for the field in which we want to replace whenever this is loaded into the UI. In this case, we're looking at source IPs, so we're going to include the source IP variable at the end of the label. Now, we only want to apply this workflow action to any events that have the source IP field in it. We want to show this action in both the event menu and fields menu, which we'll get into in just a second. And then we want to the action type we want to use is a search, because that's what we just used a second ago to actually manipulate the list. So we go in, type in search, we copy in the search that we had before, and we make sure that instead of 888, what we're going to have now is the same variable that we used in the label, the source IP variable. So that means whenever we perform this workflow action, it's going to take that source IP and replace this variable with that IP, so it performs the correct query. Now lastly, we want to make sure that we run this within our app, so we select our app, the Firepower Splunk CL19 app, and we go ahead and hit save. Now here, we're just going to test to make sure the input lookup and workflow action are working correctly. So again, we're going to load up the threat dashboard. We're going to click on one of the IPs in the top targets, which then drills into the search available within Splunk. Now from this search page, we can see the entire event information. Once we expand one of these events, we can then see the list of all of the fields and values, and we can see the dest IP and source IP that are available within this event. Now from here, once we click on event actions, we can see that the workflow action we just created is available to block a source IP in FMC, and it has replaced that variable with the correct source IP that's within the event. Now here, we did good. We added a source IP workflow action, but also we might want to block a dest IP depending on the direction of the attack or the direction of the event that happened. So we want to make sure that we have another workflow action for blocking a destination IP. So to do that, we went back to workflow actions by going to settings, fields, workflow actions, and then we're just going to clone the source IP action. And by cloning, it just copies all of the settings from the previous workflow action. It requires you to add a new name. We're going to name it block dest IP. We're going to change the label to be block dest IP. We'll make sure that it only applies to events that include dest IP. And then lastly, we're going to make sure that we change the variable to be dest IP instead of source IP. Now, we have to make sure that the search string itself is now using the dest IP instead of source IP, so that the correct IP is added to the blacklist. Now here, we'll go ahead and hit save. And now we see we have two workflow actions now, one for block source IP and another for block dest IP. So we'll go back into our app. We'll just make sure that both of them show up appropriately. So now we can see we have two options now. We have either block dest IP, which appropriately has the IP located in the string for the label, and also block source IP, which again has the correct label. Now here, you can see that you can either click on the event actions or the field actions. That was a selection made within the workflow action configuration. So here we're going to go in and actually block an IP. So we're going to use the top attacks widget, but the problem with looking at the top intrusion events that occur in your network is that a lot of times it's very noisy. We can see there's 1,700 events here. Going through all those events, while could be interesting, normally it's just noise. So looking at top events is not really what you want to do. A lot of times you want to look at the rarest events that are occurring on the network, especially when it comes to intrusion. So we're going to go ahead and change this dashboard to no longer be top attacks, but now rare attacks. So to do this, we're going to edit the search, and instead of saying top, just put in the rare. Okay, and this is just going to reverse sort the intrusion event messages. Again, we'll change the label just so we're looking at the right things. And now we can see the events are happening least frequently on the network. These are the ones you really want to drill into. When there's a real attack on your network, normally the ones that happen very infrequently are the ones that are most concerning. So we'll go in, look at this attack that's occurred. So it's a PC Anywhere remote code execution attempt. Go ahead and try to click in, but we couldn't. One thing, whenever you add a new panel, you want to make sure that you set your drill in actions. This allows you to do another action after you have, when you want to actually look into more information about that particular field. And there's many drill in actions available. You can link to a search. You can link to another dashboard if you have a flow of dashboards to go through. You can link to a report. But in this case, we want to link down into the Splunk search itself. Set up auto, hit save. And then we'll go back in and actually drill in to this action. So now here, we have the actual event that had the remote code execution attempt. And we can see the dest IP was this remote IP of 20.2.185.27. We're going to go ahead and block it. It's then going to spawn the query that we had before, which is going to include or append this IP into the input lookup. So now we can see that after this query successfully ran, we now have the IP 20.2.185.27 available in the input lookup, which we're now going to import into TID. And to do that,
So this was fun, right? So now when you're looking at the Splunk instance, you have an option to block IPs. So now is the time to actually make it actionable because you have a list of IPs you want to block, and we did cover Cisco Threat Intelligence Director. So what we're going to do now is actually import that source that you configured in Splunk into Threat Intelligence Director. So let's go to the sources page. So in the sources page, I pre-configured block list from Splunk, and now we are going to go look at one of the feeds. In this case, we are interested in the IP feed because that's what we just configured. So when you look at the options in the source detail page, you can see information about the source. So for example, this source was a simple intelligence list, so you see the file type as flat file. It contains IPs, so the type is IPv4, and you see a URL. So this URL is pointed to a server running on the Splunk instance. And we are pulling down a file called block.ip. So we just generated a file called blacklist.ip.csv in Splunk, right? And you're wondering where the block.ip comes in. We'll cover that. But what this is basically doing is we have an intelligence source configured, which is going to the Splunk server, pulling down the file called block.ip. And what Cisco Threat Intelligence Director allows you to do is configure things like what action would you like to take on the source? Do you want to block it? Do you want to monitor it? And how often would you like to go check for new intelligence? So based on that, the configuration you set, you can start importing intelligence. So in this case, you can see we've set up the path to the Splunk server, and we set the expiry date for this intelligence to be 90 days. So after 90 days, we'll get rid of this intelligence. And let's go look at the indicators page. So the indicators page basically lists down all the intelligence that was contained within that intelligence source. In this case, the intelligence source contained an IPv4 address, which was the one you blocked in Splunk. So let's go look at the detailed view for this IP address. So when the detailed view opens up, what you're going to see is you see all the information about the indicator, like a description. So let's say if your analyst added some information about where did this indicator come from, you can add that. You can also see the time it expires at, what the action was set. In this case, this is a simple indicator. By simple indicator, what I mean is you configured a list of IPs to block. So every indicator basically just comprises of one IP. But let's say if this was a complex indicator, you could actually have a relationship here in the indicator pattern, which would show you, hey, maybe it's a list of IPs that you want to block, and if you see any of the files that are downloaded from that IP location, block those as well. So you can define complex relationships using and or mathematical terms. And you also see other information about the indicator, like which source it came from. And you have the ability to even whitelist the indicator if you do choose so. So next, we go down to the observables page. So in the observables page, it basically lists down all the observables that were in that indicator. In this case, there was only one. So you see an IP there. And then you can actually drill down and take actions per observable. So if your indicator contained 5 observables, you only wanted to block 4 and say monitor 1. You can go to this page and change the action on a per observable basis. And you can also see how many indicators actually contain that IPv4 address as well. In our case, it's only 1, so you see that configured as 1. And you also get metadata like when it was last updated, so you know when it was polled at, and when this observable is going to expire, which in this case is 3 months. So now we're going to go back to the Splunk demo, and we see how you can add one more IP and block that using CTID. But before we end up doing that, let's solve the mystery of the script, right? So you saw the block.ip script. So if you're looking at this bash script here, this is running on the Splunk server. So what it basically does is it looks at the blacklist.csv file you created in Splunk. Now, whenever in Splunk, using the lookup table, you select an IP, it gets stored as an IP enclosed in codes. So for CTID to ingest the IP, we need to get rid of the codes. So this script, all it does is it extracts the IP from within the codes, puts that in a new file called block.ip, and moves it to the web server location. And this script is available in our sandbox lab, so you can download it and run it on your server. And what this script also does is it runs frequently. So let's say if you keep going to Splunk and keep changing IPs, adding IPs to block or removing IPs, it runs, for now we've configured it to run every 10 seconds, so it will generate an updated file and put that on the web server every 10 seconds.
Okay, so we've shown how to add new IPs to the block list within Splunk. We've shown how it works in TID. We're just gonna do it one more time to see the whole entire flow of how it works from start to end. So going back into Splunk, we're gonna go back into the threat dashboard, and from here, we're gonna find another event to investigate. So we go down, look at all of the different rare attacks that are occurring. Another one of interest is this database buffer overflow attempt. And from here, we're again going to drill into the search. We're going to then expand the event, and we're going to block this dest IP by using the field action there. So again, we clicked on field action, blocked the IP. It's now going to append the IP to the blacklist using the same query we went over earlier. And we'll now see we have two IPs, the .27 and .60 available within Splunk. Now, last thing we're going to do is also add this other source IP, the 10. IP. Now, we don't actually want to block this IP. It could have been by accident that we added this IP. So how do we clean it up, right? Using that same app that I showed earlier, the lookup editor, within Splunk, you're able to manage your blacklist. So now we can easily go in, look at the IP blacklist.csv, and easily remove any IPs that we no longer want to blacklist into TID. So it's an easy way to manage your blacklists within Splunk itself. Now from there, we go in and check TID to see if the IPs are now available within there. And we can see that we now have two IPs available within TID. The 202.2.60 and the 202.185.27. Both of those are now available within TID. They'll get sent down to the devices and we'll start blocking any traffic going to or from those IPs. Okay. So going back. So today we've gone over how to enhance a Firepower Splunk app to add additional visualizations that are interesting for analysis. We've modified the Splunk app to be able to blacklist observables. We've demoed how to integrate those blacklisted observables into Threat Intelligence Director. And then lastly, we demonstrated how to blacklist, again, using Firepower. Now, these same mechanisms can be used outside of just IPs for also domains, URLs, and file SHAs. So any of that information that's available within your Splunk app can be used the same process to blacklist those IPs to your Firepower devices using Threat Intelligence Director. Now, there is an exciting new announcement that there is a new Firepower app for Splunk being developed right now. It's in its beta phase. It will be released to Splunk base pretty soon. It has new advanced intrusion event analytics capabilities. It also can link into the FMC's file trajectory, and as well as Umbrella Investigate. It's got feedback from customers, engineering, the Talos group. It looks really good, and you guys should try it out. If you're interested in trying out the beta, go and reach out to this email address. Again, it's in the presentation. Also including the Teams room as well, if anyone's interested in reaching out and trying it out.
Your feedback is really important to us, so make sure you do the online survey, and I guess you get a free t-shirt if you do 4 of these, so that's a win. And you can do the survey using the mobile app that you have on your phone. And if you like to continue your education, by that what we mean is we do have this lab available on the DevNet website. The sandbox is there, so you're free to reserve the sandbox and just do everything what we did today by yourself. And we also have Threat Intelligence Director running in the security challenge. So if you go down to the booth that's just right behind you, you can actually play a ransomware game where you block a WannaCry attack and see Threat Intelligence Director in action where it's importing all the intelligence, play around with the UI and get familiar with it. And you can also schedule meet the engineer meetings and have a one-on-one with us if you like to do so. And we'll also be available in the DevNet zone, so if you have any questions afterwards, feel free to come over and talk to us. And if you would like to learn more about threat intelligence and how Threat Intelligence Director works in detail, You should definitely attend the session by Pramod Chandrasekhar on automating threat intelligence using Cisco Firepower APIs. It's going to be in classroom 2 at 2 o'clock, and he's going to actually do a deep dive using TID and showcasing how you can block a real-world threat scenario. Thank you. Questions?
Say it again.
Okay.
Is the Splunk API demoed or the new Splunk app?
The new Splunk app.
Is it available for
Okay. You can have firepower with
Yes.
domains. Okay?
domains? Yes.
So what you said, the example that you had there with source IP, I mean,
Yes.
it couldn't make sense if you have a multi-tenant environment because the private IP can belong
Sure.
to. Okay.
Absolutely.
So is Splunk ready? Splunk app, the new one, ready for this?
So is this change
Thank you.
available to use overlap IP space with domains? So in this case, that's an interesting situation. It would go down to all of them. So no, in that case, the IPs would not. They might persist across different domains. But normally, I'm not sure you'd really want to block your internal IPs. Normally, you'd want to block the external IPs. So yeah, it's an interesting use case. We'll look into how we could potentially support that in the future. But yeah, it's an interesting question. Any other questions? Okay. All right. Thank you.
Thank you.